The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. It was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
We are the Hawaiian Volcano Education and Resilience Institute, HVERI for short. A lot of people know us from the 2018 eruption of Kīlauea in the Lower East Rift Zone. Working under Hawaii Tracker on the Facebook group. Since then, we've been trying to carry on and take the lessons, the hard lessons that were learned during that eruption and try and prepare for the next major disaster that comes to our island.
Yeah, and so we do that through two different programs. One is volcano education, and the other part is digital resilience, which we address through online groups on social media. So the way the two programs work together is that the social media networks end up being a distribution pathway for all the information. And having that network in place means we can provide more than just volcano education, but any other preparedness information as well.
What we were working for really came about in the Maunaloa eruption in 2022. Within hours of that eruption starting, we had the mayor, Mitch Roth, we had USGS-HVO Ken Hahn on the stream trying to help flush out a little bit of the ongoing because it's so new. It's completely different from our previous major eruption, which was 2018.
One of the things that Talmadge and I were talking about was how do we deal with social media? It was something we needed to figure out and get right. Our job is to get information to the public and make sure that the public get it as well as possible and as correctly as possible. When Philip and Dane started coming to and live streaming the meetings, it was great because we were reaching more people than we normally would. So when the eruption actually happened, we had this relationship. The interviews we did during the eruption, the most fun ones were the ones with Philip and Dave because they were more relaxed, and we knew we were getting to the local community, and people were asking questions. So those were the best. I think I just want to really give a shout out to those guys and how we worked as a team on this eruption. It really worked out well, and we got to a lot of people we wouldn't have normally gotten.
Hello everyone, and welcome to our Hawaiian Volcano Tracker for December 4th, 2025. I'm geologist Philip Ong, here with Mr. Dane DuPont. We got Luatori on the back end, and our ASO interpreters, Dano and Carrie, are back. Appreciate everyone here. We are the nonprofit HVERI, the Hawaiian Volcano Education and Resilience Institute. And today we're going to update you on Kīlauea, which is in its pause following its latest episode, number 37. So that's a little bit of what we're talking about today, as well as the anniversary, the 50-year anniversary of the 1975 earthquake, which is called the Kalapana earthquake, was underneath the south flank of Kīlauea, and caused a tsunami that was fatal, hit the campground at Halape. And so we'll talk about that a little bit too on the back half of our show today. How are you today, Dane? How's your week been?
Doing good. Yeah, we've just been busy with some projects and trying to wrap the year out and try and stay dry in the meantime down here in Lower Puna. It's now picking up with the rain. I don't know if you guys can hear it, but hopefully it calms down a little so I can hear everything.
Oh, interesting. Yeah, a few miles uphill over here. It's not been wet at all today.
No.
Interesting. Yeah, our microclimates up here.
Right.
All right, so let's get into it here, huh?
Yeah, let's do it.
Yeah, as usual, Dan and Lou will direct our discussion on the chat, collect some questions for us to discuss. And all that said, let's get our screens ready. All right, get our screens ready here. And here we go. Hello, everyone. This is our Hawaiian Volcano summary for December 4th, 2025. In the week following episode 37 of Kilauea's ongoing summit eruption, the volcano has been fairly quiet, just glowing and flaming and degassing. As you can see here in this view from the V1 camera, live as we record. However, in the last couple of days, we've had a subsidence or sinking episode that occurred in an area where lava typically ponds near the vents on the west side of the crater floor. It's a small area, which you can see in our time lapse from the KW camera here, that over the last couple of days, it has undergone some sinking in a central area that we've seen sink before, right? Perhaps through some draining into some underground network here. So here's a different view from the V2 camera, which if you look at the bottom left side here of the screen, you can see the ground dropping just over the course of this morning, is this particular animation here. So all this corresponds, if you look here at the 3-month tilt on Kīlauea Summit, we are overall recharging since episode 37, building towards episode 38, which the USGS expects within the next week. But just within the last few hours of this morning, we had a very small deflation event, which corresponded with that subsidence event at the surface as well. So perhaps there is some connection and some effect that may slow the forecast from the USGS, which currently is between December 6th and 9th based on the ground deformation models here. All that based on overall inflation, continuing glow from the vent, and intermittent spattering. We have a new map released of the eruption area at the summit of National Park, with all the impact within the inner crater of Halema'u within Kaluapele, the greater caldera. So earthquakes have been fairly quiet this past week, following the previous week's magnitude 4.6 in the south flank. We have a more typical pattern of south flank events continuing, as well as a resumption of summit events leading up to or following our episode 37 as well. That complements our largest earthquakes this past week, which have been down in the Pahala region, colored in blue at this greater depth, connected to the hotspot feeder to the volcano. Overall, our earthquake counts per week have fluctuated some, with that peak last week at a magnitude 4.6, but you can see we're back to our lower value, and all this within a lower average, which has been our normal ever since the onset of this eruption nearly a year ago in December of 2024. The biggest impact of people is still the VOG. Here you can see the VOG forecast with mostly trade winds affecting southwest Hawaii areas and occasional slack winds affecting areas to the north. Current conditions are looking pretty good, with a purple air monitoring network showing most signals in the green island-wide. However, our satellite mounts data software is showing us that we've had several dispersions of SO2 across the southwest over the last few days here, large enough to be picked up from space. So even between episodes, these emissions can be large and considerable and impact water people living in these areas for a long time. At the start of the month, we have a new monthly update from the USGS on Maunaloa, which notes a return to background earthquake rates in November. This is following a higher level of November. We're down to modestly higher rates for the last month here. They also note that GPS instruments showed a slight increase in inflation, which is normal as a volcano recovers from its 2022 eruption and magma replenishes the system. So they note recent data indicates the center of deformation shifted to the southern caldera region, indicating a refilling of the south caldera magma chamber there. Right. So this has led to some slightly different patterns, but overall, after that spike of earthquakes that was indicative of that process last month, we see here a return to our background values for Maunaloa, which are pretty low for the last year, and certainly low within the context of the last 5 years, including the buildup to the 2022 eruption that you can see plotted here. So the nuance is that the volcano has been contracting at its summit with that shift to the south caldera, while the up and down signal has stabilized as well. So that's our summary for this week. So let's move on to our hazard summary here and look at the gases that come and go. And starting off with this close-in view of the S2 camera, showing you guys just the daytime views, with mostly trade winds blowing the gas off to the top and left, but you see occasionally it is flipping around. So we're getting more frequent periods of Kona winds or slack winds that bring these fumes over to the right side of the screen, which is towards the national park viewing areas and further afield towards communities in the volcano area. So that's the close view with the S2. I'll move on to the K2, which is from the top of the crater with a Huna overlook, former site of the museum. And similarly, you can see most of the time the fume is blowing off into the desert, but occasionally it blows back this way or towards the camera. And of course, I'm only showing you the daytime views here. So that is the biggest impact to be aware of here. And finally, the most zoomed out view, the KP camera from the side of Maunaloa, showing the crater and lots of weather coming through here as well. And you can see that cloud is flopping around all over the place here, not only hugging the ground to the bottom on the right here. Can't always see it there with all this fume in the way here, but if I can zoom it in perhaps, you might know how sometimes it's hanging off this way or going more over here. And that's the VOG dispersal over the past week. As usual, we like to turn to the VMAP, VOG Measurement and Prediction Program, and their VOG forecast dashboard here, which is currently showing all the SO2 monitors in green around the island and statewide. And given the current 1,500 ton per day emission rate from Kīlauea, this is the VOG forecast for the next couple of days here. As usual, you see lots of Pahala Ocean View, Nalahu area, wrapping around the South Konamilui area as well, with this occasional wafting north across Kulani into the Saddle region too. So it's not as bad with this lower emission value, right? But one thing to be aware of is we noted that USGS ahead of episode 37, this most recent one, for those 2 or 3 days ahead of the episode actually fountaining, this is during that overflow phase, they noted up to 3,000 to 4,000 tons of SO2 coming out each day. So this could double from what we're seeing now and still not be the full blast that would get during the high fountains. So it can certainly be significant for people who are living nearby, especially if they have respiratory sensitivities. So we'll look at some of the monitoring signals. This is the state air quality data website with everything in the green. It does show some higher values, getting close to the threshold of yellow, but not quite. So certainly there is impact. It's just still in the good air quality index level. Going to the purple air network, which we prefer because of the greater number of data points. You can see here lots of green. Remember that this is picking up particulate matter, so it can pick up dust and fire products, that kind of stuff, ash, as well, besides the volcanic fumes that are producing sulfate particles too. So all that said, we'll go close to the national park at their website for the air quality and show you that mostly it's in the green, but down at Kahuku, the SO2 unit is registering lots of periods of time that are unhealthy or even very unhealthy over the past day here. So depending on the direction of the wind, if it's blowing it right across that sensor, in this case at Kahuku, or someone's house in Ocean View or elsewhere by Kahuku or towards South Point, then you could have a similar effect as well. So that's what to watch out for. Turning to their map, everything is plotted as green, even over here at Kahuku. And remember, these are just taking 15-minute averages, so there could be spikes from minute to minute that are not registering in any of these maps whatsoever, but could be very real for you if you're in the area and experiencing it firsthand. So coming back to our mounts project here, we can rewind back to before episode 37. Here's our satellite capture of this pre-fountaining phase SO2 output, in this case blowing trade winds, in this case blowing Kona winds more to the north, not quite reaching Hilo Bay. And then here is the actual main blast of outgassing from episode 37. You can see it's caught after it's drifted a little bit off the island to the southwest. You see those bright red colors there, a massive injection of sulfur dioxide into our atmosphere here. And so that was the 26th. The next day, you see it somewhat getting reworked and swirled back around. So you see it's still here drifting, but reshaped to our south. And then we have the calm after the main burst with just high levels of SO2 before resuming our inter-episode SO2 emissions. And in all these captures, we're getting it going south or southwest, although in some cases at seemingly higher concentrations, you see we're getting some blues and even greens on here on this particular capture on the first. But otherwise, that's what we're seeing here. And to zoom it out and wrap up our gas hazard, here's the windy.com SO2 layer. And you can see there the broader picture of where this SO2 is drifting across the Pacific Ocean and drifting across the rest of the globe as well. And look at that. Many of the continents, especially all the northern hemisphere, all have a whole lot of SO2 over them right now, right? North America, all of Europe, all of Asia. You gotta go to the south here to find any kind of SO2 free air at the present. All right, so that's our gas, and what we're going to do next today is move into our monitoring. And so just start off with today's daily update, right, which notes that inflation resumed midday yesterday, noting it had stalled before that, continued until 5 a.m. this morning. Slight deflation on the summit's occurring now, and that was when written at 9 a.m. as that subsidence event at the summit, the sinking event, was actually occurring. They note overnight moderate glow was observed with flames from both vents. They note persistent low to moderate tremor, with seismic tremor bursts punctuating the signal that suggests irregular gas pistoning at depth, right? So that the gas lifting that degassed magma, kind of spattering it out, essentially burping out the gas, then the magma falling back down, and that process, the column rising and falling, that looks like a piston, and that's the gas pistoning process that we refer to. Weak spattering intermittently observed at the south event in webcams, and that's the summary of it there. And typically 1,200 to 1,500 tons of SO2 per day, as we noted in our hazard summary. No changes in the rift zone. No real changes here. They do note December and 7th, the most likely time for fountains to begin, with the larger window from the 6th to the 9th. But it may change if there are more episodes of deflation or periods of slow to no inflation as well. And one thing that's interesting is when we've had some of these signals before, and these extended buildups to the fountains, we've sometimes had, we've speculated perhaps that if there's more of this degassed magma draining and mixing in there, then you can have a prolonged period of overflows also ahead of your fountain, because you have more stuff that's in there you got to clear out, if that makes sense, right? So the material we lost today shifted today, didn't lose it, it had to have gone somewhere, right? So we won't see signs of it moving elsewhere. So you might speculate that it could drain back in and then have to get pushed back out when these overflows come in the next week or so. So we'll wait and watch and refine our theories here, and try to learn from what the volcano is doing so we can anticipate what to prepare for should this ever occur in our neighborhoods once again. So that's the text update. I did show you guys this map that was put out last week, and just to restate here, we're up to 185.5 million cubic meters right there, or 49 billion gallons. That's just a huge amount. It's hard to really have that mean anything to anyone, honestly. Just a massive amount of rock that's filled in the pit that used to be 1,600 feet deep here just 6 years ago. So moving on to the monitoring signals. Here is our laser rangefinder, which is showing just daily variations. You have to always look at the scale of these graphs on the side. And so here you can see the scale is showing us decimal points of a meter. Right? So this is within the error range of the reading anyways. And so these are variations, perhaps based on temperature of the sensor or something along those lines. That's just causing slight fluctuations in reading here. But we gotta zoom it out. Right? So here's a last week of tilt at the summit and rift, summit in blue. And here's the beginning of the day at midnight right there. And so here's our daybreak deflation episode right there. And that corresponds to our subsidence event. And you can see since then it's picked back up, resumed inflation at a little bit of a healthier rate as well. Meanwhile, no connection at all to the green line, which is the pool crater tilt meter, which is showing mostly this flat, slight decline here. The earthquake counts, we're still once again zoomed in. Our background value long term is about 30, so we've mostly been below that with a few extra clusters here earlier on in the week, as you can see here in the south flank. Maybe these are a little bit more of the adjustments that occurred on a flank following the previous week's magnitude 4.6. So just over the last week, here's the map, as we showed you earlier. I'm going to show you guys that in a month-long viewpoint too. So here's our laser rangefinder once again, and here you see the fluctuations, those little variations daily, showing us these little wiggles. But really, we're looking at that average value of the ground surface being something like that. So maybe slightly sagging there where the laser is pointing. Nothing completely dramatic like we saw further over where the laser is not pointing, where the time lapse caught that sinking earlier today. But if we were lucky to have the laser pointing there, you might see something like that, right? And then some stabilization. but we have not seen that there. We instead see the jump when lava flows come and flood the area and thicken it by several meters at a time with each episode here over the last month. And there's a ground tilt that accompanies the onset of each episode, the deflationary drop that is happening at the same time as lava is leaving the ground. There's our earthquake spike from last week and our recovery most of the way since, right? So you can see we're not too far off this very similar threshold. But yeah, about another week there, depending on whether the rate is more this way or more this way, and how many more of these little wiggles we get to slow us down. Turning back to the Mounts project here, I want to show you a couple of things. First is this capture, the infrared showing you lava flooding the crater floor during episode 37. Looks like the well, I don't see an actual channel between the vents and the flows. I mean, it might have just ended right there, and the lava is just pooling, reaching the far edge there. But that's pretty cool to see, caught there once again from space. And then we also have our ground height measurement, which we call INSAR. It's our satellite aperture radar measurement here. Try to not put any more jargon in besides that. So, but here what you're basically seeing is the time frame between the 30th of November and the 24th. This does catch our episode 37 drop. So mostly what we're seeing, the net change here is a deflationary signal of the ground relieving pressure from having its episode 37 of its eruption. Right, so it catches a little bit of that plus the recharge since then. So it's a little bit of a mixed signal here, but it's still a net loss, with the center still being over here in this central area, eastern area of the main caldera. So we won't try to analyze anything beyond that, as it's a little complicated here this week. But we can compare it to the previous snapshot there, right, where we were just building up to it, and you can see similar patterns of concentric colors towards the center of the crater here. So that's our main monitoring signals. We'll do our earthquakes next. Just to show you here, to start for the last week, colored by depth. Most of these are the blue ones. The Pahala source has been fairly active, including one larger event here that we'll look at in a minute. With several aftershocks clustered around it there, but all these other blues and purples are also settling events around the island. The island's got its own structure, its own weight, and it's moving over this zone of heat that's a hot spot. So it tends to rise and expand when it goes over that area. Then when it moves over that over the course of billions of years, it's sinking on the other end. So it's almost like going over a bulge, right? So as it happens, the whole crust under the island settles and adjusts, and so you have all these background events that show up like this, these blues and purples all across the board here. And that's the base of that stack of the crust there, but you can get them all the way through to the top, which can be these oranges and yellows as well, and reds as well there. But we often look closer in to this eastern flank of Maunaloa, which has only a few adjustment events here between Maunaloa and Kīlauea. So that seems to be happening still, but nothing really noteworthy there. And Kīlauea having her events at the summit and on the flank here as well, with a deep Pahala zone overlapping there. So nothing really noteworthy for the past week. Looking at the earthquakes by size, zoom it in a little bit here. Our 3.5 in Pahala on the 29th, 20 miles down deep, that deep hotspot source being the largest. And the next one is quite a bit down, 2.8, also deep Pahala, connected with that same series. And then after that, we have a 2.5 offshore of Kona, 27 miles down, also that one more of a settling earthquake. So you see how there's fluctuations week to week across the mountains, each volcano, even the background events, the settling. So a little bit quieter this week, and that's also normal. So now we'll go to our observations, our visuals. And I'll start off here by showing just the view of glow for the past week. This is the S2 camera. So this is a south vent on the left, north vent on the right. You can see this south vent with lots of glow consistently, north vent joining in more recently as well. That's what it'll look like overnight. But we also have a release from the USGS Photo Video Chronology from December 2nd, showing 2 videos. So start off showing you guys this shorter raw video. There they are in a helicopter, zooming in on the north vent. You see several different holes there, right, of that vent complex, which is why we're having those multiple fountains shooting out different directions. South vents over here, further over, and we'll see that as well. But let me try to zoom it in for you guys. You can see a little better there. Lots of exit points there and glowing spots. See the gas mostly coming out from this one area right over here in the north vent, and also the south vent over, which is building a nice sulfur bank above it as well. So that's one video, and here is another one, a little bit longer. So there they are, landing in a crater floor, collecting lava samples from episode 37. See the ground steaming there. View the vents from across the crater floor. We're flying over, looking at the lava channel against the wall of the crater there. You can get a visual here of about how far it is from that lava surface to that next ledge of the crater floor. And rewind that so you guys can see that again right there, that distance right there. And panning around, everything to the right of the vents here is all covered in tephra from the lava fountains. That's basically that frozen lava spray, right? It's hardening and falling down as actual little rocks. Here we are looking in north vent. You see that lava surface spattering and bubbling down there. And here the south vent, not quite as good a view, but you can see the red right there also through a lot of fume. There's tephra all on that backside, covering much of the landscape, covering cracks, covering lava flows here. So remember, we talked about lava fountains dropping lava and causing cascades back in a crater and off the far side. That's what you saw there. So I'm going to do it again here, but now let me try to zoom it in a little bit here. Yeah, it's pretty incredible. They're making it routine now to line on the crater floor to collect these samples. I think they've got a pretty good repository, we'll call it, right, of different lava rocks. The textures are really incredible there on the crater floor. You see them changing every episode. There's features that come into being there and then never even get named or anything, and then get completely swallowed and remade into something else a few weeks later. There's our spattering surface there. And our south vent. A little bit of lava shining through the fume. And there's that little lava flow right there. It's just puddled over here, just over the rim of the crater. 950 acres of crater floor covered. So that's the video release from USGS here. And they have some images that go along with this as well, from the ground as well there. Looking straight down, similar captures as we just saw. We start contrast the colors. You see the road that's being maintained by the USGS driving across it to continuing measuring and sampling it. And so they're crushing that rock there, and little bits of tephra to go and continue to measure that slope in the back, which will be something we talk about in Volcano Watch today. And there, once again, is that little lobe of lava right there. Several different ones that flow down from the lava spray landing on the rim of the crater here with enough volume to actually coalesce into a lava flow and ooze a short distance. So that's one of the cooler things to me here. It's interesting that I know here this was the only lava flow on a crater rim so far in this eruption. Episode 34. Some other images from the crater. Here is the crater floor. And here is looking up from the crater floor. So right down here in the bottom, this little black thing is a lava on the crater floor, right? And this right here is looking at this wall to the next level of the crater floor there. People are asking how much lava has got to fill a crater to overflow to the next layer. There it is, right there in one point of view, and here it is with someone right next to it, below it, looking up at it, so you can have a clear idea in your mind how much it actually is. Right, we're talking about 300 feet, and so they actually write in the caption here. The Volcano Observatory often gets asked how long will it take lava flows to fill in the crater and spill onto the upper caldera floor of Kīlauea. Which is interesting. So that's the question that they pose there, right? Which they're don't think they're going to answer it, but they're going to give us some clues here. They note that lava flows at the base of Hawaii Maumau have this average elevation noted here, and the floor northeast part of the caldera floor is an elevation noted here. So that means a difference of 300 feet or 91 meters of lava is needed to fill the crater before lava flows spill onto the upper caldera floor. So that's great, 91 meters, 300 feet, but we also need to know the area of the crater and then the filling rate to try to figure out how long it would actually take. So that's really a really hard thing to do, and especially to have any kind of accuracy looking back when it comes to be time months from now. But so 300 feet, 91 meters, that's what you're looking up at. This cliff here is a 300-foot cliff of how much lava is going to fill that area looking across this entire landscape over here for it to actually spill over. So that's the interesting thing that they're noting there. They do include another image here, Maunaloa, Mauna Kea, and Kīlauea here in the foreground. 3 volcanoes there together. So we did try to do an exercise on this in the past. If you've missed this from us before, we have maps. The USGS reports their volume at certain points in time, and so we can do a long-term filling rate, right? This is the volumes here, and projection. And what we actually have is hard to read on here, but we have several DEM measurements from the data set the USGS provided following the caldera collapse, that we have estimates of volume to fill to certain elevations, essentially, right? So there's some assumptions you make there because the ground isn't exactly level. There's a slope to the ground. There's, the rates vary. It's not exactly a perfect funnel, all those kind of things. But if you're looking at, maybe I'll have to read this here. For the volume to reach the caldera floor, that's this value right in here, this volume amount that would take. And so that, from our estimates, would put it out right around September 2026. Which was about a year out of when we made this, right? But maybe it's getting closer to 9 months, 10 months away at this point, right? So we've had eruption going on for 11 months. Can it do another 11 months? That's what you're really looking at. If we're only halfway there, then we can get to the point where we're filling and spilling out on the caldera floor, right? But if we're not halfway there, or if anything changes this, a big earthquake, intrusion into the rift zone, either one of the rift zones, any number of things. We could go from there, right? I can have to keep naming things, but that could upset the system here and cause us to not have a full year and a half to do this, or full 2 years to accomplish the filling work. So that's really the question there: is how stable will it be without something changing before it gets to that point, and how fast can we keep up this rate? How long can we keep up this fast rate, is what I should say. All right, so if we're interested in some other numbers beyond that, to near overflow of the Kīlauea Rim at 1,100 meters above sea level, that would be May 2027. And if you're looking at the full volume loss, that was from 2018, which is broader than the actual hole, because the sides of the crater sagged in too. So if you want to recover that entire amount of lava overall in the system, then you're looking at something like over 2 years out into February 2028 to reach that kind of volume. And that, of course, is a much more tenuous proposition there, a much less likely thing to happen. If I've got doubts it'll go for 1 more year, then what about 2 or 3, right? That's what it would take to get to that point. So that's our visual there. And we can have another live look in. Here's our V1 camera. As it's getting dark here, we see the crack glowing and flaming, venting gas as well. Here's the V3 with the sulfur banks on the hill behind it, fuming as well. And the V2 camera, which is catching a bit of both. You can see the glow even from this angle all the way over here. South vent, north vent. Pretty foggy in there right now. And so what about this last week? So the V1 camera, starting with the fountain, episode 37. And then you can see that crack is already there, glowing and fuming ever since the day after that episode ended. We have more glow and even some spatter coming from the main throat over here, further to the left. Even as this crack continues to glow, you can see that. And over here in the foreground, we have another glowing crack too, which we saw slumping a couple weeks ago. It seems like that's still hot on the inside there too. That's our V1 camera. There's a nice view of the north vent. Here's our V3 with a south vent. Here in the bottom left, you see the glow. The north vent's over here behind the ridge. So we just see it's a little bit of spatter, strong glow there. Lots of gas obviously coming out. Look at all that sulfur building up on there. And finally, our V2 camera. There's episode 37 for its 9 hours. I like this angle because you can really see the slope from the base up to the top of this broad lava shield with the vents towards the top back wall. Some camera movement. There's a south vent glowing more. The wind changing direction there a little bit. Again, changing, swirling around during these few days here. And focusing on events, you can maybe miss it, but let me pull it back here a bit to the third, and let's focus down here on this bottom corner. And there's our sagging event right over here in the corner. So once again, let's show you that. Zoom into that area right there. And it's hard to get scale on these things, right? But that looks like it could be several meters, if not 10 meters of drop right there in the center of it. And you can see it's a pretty broad area. I mean, it's a fairly small area of a crater floor, which is pretty huge. But if you're standing there, that's got to be, bigger than a parking lot, right?
Yeah, I'd say more than 10 meters, 20 something feet.
30 feet or so,
Yeah.
maybe 20 meters.
Yeah.
And, it's hard to tell, right? There's nothing to compare it against. I don't have a helicopter flying in here again, but right, that's a pretty big hole. It's small compared to the size of the crater. But
How long was this time lapse over?
this was just from this morning, from daybreak.
That was just from this morning it did that.
Yeah, from this morning till about 1:30 is what this particular loop that you're seeing right here is.
It's going somewhere.
Yeah. So that's
See
the
from back
yeah, that the V2 view, right? We can look into this a little bit more, but so here's a tilt once again, and 2-day tilt, so you can see from like 6 o'clock this morning, maybe a little bit before that is when this actually going to actually start. So it only lasts a few hours, and then it turns right around. So looking at a thermal, here's actually the whole past week on a thermal following episode 37. You don't really see much, anything change. It's more flickers of the scale changing and the camera adjusting. It's field of view there, nothing really until the very end here, where you can notice our most recent frame is picking up a little bit of heat at the edge of this sinking crack, right? There's kind of cracks there along the edge of this, almost like a sinkhole in a way. Right, and there's releasing some heat there along that margin, and a little bit more broadly here in the foreground. So let's look more closely at just the last couple of days here. Oh, is that it? I got this thing in here twice. Yeah. And here we go, last couple of days. So you start to see the crack form. Gets a little bit bigger, but that's kind of it. So there it is. Up area of pooled heat from before, where lava's been ponding in this area before, and then there's that crack starting to form. And there you go. And from a KW camera view, zoom it in. As you see, it's catching the edge of this black flow right here. Part of it is collapsing in there as well. All right, something like that. And that's really it. Not a lot of other changes by the vent. Let's see other changes in the flow elsewhere from this angle. We have one more view to check, and that's the B1 camera. And here, not a lot of change either. If you do look closely over the past week, there is a little bit of sinking of the surface. It almost looks like it jumps up because I'm looping it around. If I just played it once, you'd see it just gradually sink down, and that's the deflation of this lava flow that flooded the east side of the crater during the last episode. So that's normal. We've seen that. That's kind of a minor thing, but nothing really unusual happening here. So those are all of our visual clues that we have for the past week, and we're really waiting for something else to happen. But even still, there are some exciting curiosities to watch here. What about you, Lou? Have you got any other things you wanted to add in here? Some observations?
I do. But I wanted to ask you, I was working on something in the background, and you'd said the lava's covered 950 acres, or the caldera was 950 acres. Did I hear? Which did I hear?
Yeah, I think that the lava covered area in this crater right here.
Right. So, to give everybody context of what that is, that's in Central Park in New York is only 843 acres. Or for football fans, that's 720 football fields. That is a lot of lava flowing through there. 920 acres. Incredible. Thank you. Thought I would just throw that out there. Nope, Dano's getting out of here. Hi, Carrie. Thanks, Dano. All right, let's pull up some observations for this week. Fortunately, Phil didn't cover what I had on here. He definitely brought up the spattering that was going on and the flames that was going on. This is just some shots from the first that's been happening. This precursory activity, all the activity that's happening before the precursory activity has definitely been nonstop since the end of episode 37, whether it's just daytime shots of just some kind of glow out there. You can see the gas pistoning happening during the day with puffs of either just dust, tephra flying around. The glow comes in and out throughout the day. At night, it's pretty much all night out of both vents. There's only been a couple nights that it hasn't been out of both vents, including the V2 camera, which is incredibly difficult to see anything at night. It has been showing some pretty good views, including this morning with the the flames. This is an avalanche that we caught right here. Take a look at where it's located in relation to the vents. It's a long ways away.
It's way over there, isn't it?
And if you look back at episode 37, did we have fountains shooting all the way up that hill? When was the last time, was it episode 35 or 36, that we actually had all that tephra shooting in that direction?
I think 37's going to have it also, yeah.
Did it go over that far? I didn't go back and double check that. I was shocked at how far that was over. It caught my attention.
Yeah, at least 36. I don't know about
Yeah.
37. At least 36, right?
That's what I was thinking. There's some more shots of the flames, both vents going at the same time, including that's not in the main north vent. That's in that crack that you were talking about right there. All night. Very, very seldom does it just shut off. It just keeps going. There's this morning's view. Doesn't
Found a
last.
USGS note
Go
here that the poot grew very minimally in 37, so it was really 36 that
36.
dropped that lava on there. Yeah.
Yeah.
It's been a while.
Yeah. Right. And for it just to be that hot still and coming down, everybody always asks, how long does it take to cool? There you go. Takes a while. Right. So even great views out there in the morning. I have some friends that were up there this morning, and they were up there when the sun was still down, and as it was coming up, you can still see, this is off the USGS cam, but give you an idea that you can still see a pretty good view during the day up there. And you can see that one glow over in that other crack to the far right, just a little speckle of it. Here's the south vent showing off, or showing off a little bit. Some good spatter activity last night with the flames at the same time.
A little fireworks show.
Right? And this is real speed. I didn't speed any of this up.
You know, the camera doesn't do it justice either, right? It's just capturing
No.
the process rather than the beauty of it here.
Right. And we're dealing with 3 different cameras up there with 3 different settings. So lighting is always different. This is pretty amazing, even though that it's kind of blown out a little bit. You can still see the north vent over there glowing. We're getting there. We're getting there. Sometimes when I'm recording this, I just kind of get lost in watching the activity. So it's like, oh, well, that might have been longer than 30 seconds.
It's like a campfire, right? It is easy to get lost in there.
Right?
It's always shifting. If not the lava or the spatter itself, the gases can get lit up and they get brighter, dimmer, different.
Well, that's the thing.
parts
It
of them
starts
get
getting
lit
a
up.
little dimmer, so I'm ready to stop, and then all of a sudden, boom, here we go again. Big flash of gas. Let me speed us up here a little bit. Here we go. Back over to the north vent. You can see the south vent over there in full color now. You can see the south vent. I mean, still going at the same time the north vent's putting off the flames. Right there. And so this is the shot I wanted to show here also coming up. The north vent lit up right there, and you can see the walls inside the north vent. Give you some idea of it's deep. We had the overflight, so you could see the magma down in the hole there. It's got a ways to go to get up.
And several holes too, right?
Yeah.
You can see that here too.
Let's see here. Okay, so this morning, the talk again is all the sulfur out there. You know, just the V2 cam, the S2 cam, or just the V3 cam just look amazing with all that sulfur. Let me back that up real quick. This was a shot right there of tephra just flying around on the second. Yeah, on the second. Just whipping.
Just from the wind, though.
Just from the wind. Yep, just from the wind. You can see it was totally blown out of VOG up there, but the wind was definitely blowing. And this is a shot that's coming up here that everybody, for the bird nerds, right there. Did you see it? Don't worry, I slowed it down for us right there. Hold on, I'll pause it. There we go. Great shot. Right through the camera. Normally we see the owls up there at night. We see the seabirds flying around, but this was a great shot. Couldn't resist it. So there's our observations for the week. A lot of flames, a lot of spattering, good visibility. And I don't know if the weather that's just now hit me that Dane was talking about when the stream started, I don't know if it's made it up to you, but it's hitting me now. So we'll see how the weather holds.
Is that a hawk?
It's a hawk.
Here.
It is, yeah. Mm-hmm. Yep.
Yeah. Diving in there. Like it turns and dives. Barrel roll dive.
He did a barrel roll, exactly what he did.
Pretty cool. Nice catch.
There we go. Observations for the week.
All right. Thanks, Lou. Why don't you get Dane in here and take us on the community corner?
Oh, yeah. Got to have Dane, and I got something special for Dane. Don't shake your head. Here we go. What's happening around the neighborhood in the community? We have some new things going on at the park that are open. We'll cover these. Do we still have Carrie? Dano chickened out, didn't he? All right. Hey, speaking of observations, this is taken off of the V3 cam and or the V1 cam. I think this is Matt Patrick up there. But yeah, they were doing some maintenance on the camera, and I guess he needed to look deep into
it took me a second to figure out what that was. I thought it was a backpack. Like somebody's backpack in the
No, that is
Gary, do you see the face yet?
I think that's Matt. Yeah. Gotcha, Matt. Lava viewing locations all around the caldera. I shown Kīlauea Iki parking lot and the overlook, and I shot some video from out of my truck up there. This is a beautiful place to be able to view without all the there's not a lot of crowds sitting up here.
Yeah, great views all around though.
Yeah. There they are. Pretty much stop and look, check them all out. I know we're coming up on episode 38. I know Keanakekoi is a wonderful place to get as close as you possibly can, but it's difficult. It's difficult. Welcome Center is open 9 to 4:45 p.m. Get your information there. They recommend it's your first stop. It's hard to go all the way up there if there's an episode going on, but that's where you can find the park rangers and park information. Got the junior ranger books up there for your kids if you're bringing them. Definitely stop by. You look for the flagpole at KMC, Kīlauea Military Camp. You can park behind the HVO building. Don't park in front of KMC. It's reserved for guests. There's our Kīlauea Visitor Center. No new updates on that. Hopefully they'll start framing in it. I think this is just building a little bit ourselves. We know that this is the hardest part. Hopefully it's all open air, right, Dane?
Yeah, but it also goes the fastest too, right? You get to see a bunch of the visual changes every time you're at the job site. Whereas
right.
Finished work, you spend 3 days in there and it doesn't look like you did anything.
Yep. So you can tell how big it's going to be inside. Take a look. There's a lift inside there. You can see in there. It's going to be a nice big open air lanai. There's the parking situation. I'm going to talk about this in 1 second when we get to that slide. But this is what it looks like during an episode. Be patient. And I don't recommend parking on the side of the road like this. You'll get a bumper like that on the bottom. Look at what is open. I have closure still up here as a reminder because they've been closed, but they are all back open again. Kīlauea Iki Trail was closed for some maintenance. They still have some construction going on, but it's still opened up to hikers. The completion date was supposed to be on the 30th, but it's been pushed to December 31st. It seems like they are moving pretty good up there now.
Keep having to make sure you're not doing anything goofy in these photos, like that middle one.
No,
there.
these are all legit. I will put my disclaimer on them, well, or it's just obvious. There's the Kīlauea Iki Trail loop right there, and the red circle shows closure of the western switchbacks. Maunaloa Road is open, now open due to reduced fire danger. Park managers closed the road to vehicles in late July. I cannot believe that this has been going on since July. Campfires and open flame cooking fires are again permitted. One of the places we like to go up to when we have some time is drive that road, so it's nice to be open again. This is the type of place that they don't want you parking on the side of the road because the main source to fires here are people, and car exhausts starting fires is a real thing. Go ahead. Pausing. Stay hydrated. Bring your own water. Yes, I have my warning up there. It's fake.
There's
fake.
No dogs in this one.
No dogs in this one. No. I thought about trying to sneak this one past you, but the caldera floor would just give it away.
It's pretty good though. Really.
Yeah.
What one did that one?
Recraft. Yeah, but she does have a major malfunction.
Oh boy. So small I can't really see.
She's only got 4 fingers.
Oh yeah, I see that now. I mean, she has one big middle finger. Maybe that's
okay.
2 fingers.
So as long as you have,
she throws the wet side when she drinks water. Lou, you don't do that.
Gotcha. Stewardship at the Summit Rainforest Restoration is happening this weekend, December 6th. Meet project leaders Paul and Jane up there at the Kīlauea Visitor Center. Help out our invasive species issue here on the island.
You've upset chat, Lou. They want.
I've upset the chat.
Yeah, they want AI doggos.
All right, next week you'll get your dogs. Everybody, calm down. Ranger guided programs at Kīlauea Summits going on almost daily. I recommend going into the KMC and asking. Get there early. They open up at 9. Go check them out. Ask them what's going on for the day. They may have something going on that they just don't have on their website. And there may be a board out front with information. We've seen that as well. Santa is coming to Kahuku this Saturday. We'll be there from 11 to 2. Check that out. Saturday, December 6th at 11 a.m. Dane?
It's an upgraded sleigh. Slightly different than the one I grew up with.
Yeah, it's a mighty mule. One more week for the Dick Hirschberger program down there at the Kahuku unit. A lot of activity happening down at the park. Recommend getting there early. We'll cover this one more time next week, and hopefully you guys can get there if you're on the island. Recommend checking this out. And here we go for Dane. Special community event filled with food, music, raffles, vendors, and aloha. The 8th annual Ponchos Taco-versary is happening. Ponchos Tacos.
Awesome.
Support the community right there.
Rainbow.
Mm-hmm. Everybody's coming together to support Martha's Tamales and Pascual. So that's happening in Pahoa on December 16th. One more week. You should get there early if you know anything about Dane and I talking about ponchos. They are exceptionally good, and everybody knows it.
And they're always doing things for the community.
Always. Yep. That's one reason I wanted to put this up there. They do the prep fairs with civil defense and make sure that they got good food there, and Good people. So happy to put this up there for them and help support the community. And we are coming up on the last days of our fundraiser here, our end of the year fundraiser. We're still about $1,000 from our goal. So if you haven't donated, now is the time to get over to hveri.org/donate. You can donate here on YouTube in the chat. We have the nonprofit
YouTube
fundraiser.
Giving. Yeah.
You got it?
YouTube Giving fundraiser. Yeah.
YouTube Giving. That's what it is. Giving. Yep. Here on YouTube. Yeah. So that helps us out. Either place works for us as long as you can support us, help keep our digital doors open. Supports all of our programs, volcano education, this broadcast tonight, our AI and digital resilience training, and our youth leadership program. And if you have not already joined our email list, there is a way to do that by going to hveri.org, subscribe. You can do that right after you hit our donation page. Sign up for either our notification of when an episode happens in the caldera or our newsletter list. You can do that there. Yeah. And I think, Dane, do you have anything you want to say?
Point. Yeah. I'd like to thank everybody tuned in today, but also like to thank the 5i Grant program and the County of Hawaii for their support of our volcano education, but also their support of our youth development and digital resilience programs. Really helps keep these steady delivery of content to everybody. So we appreciate that, but we rely on viewers like you to, like, share, subscribe, all that stuff to get this message out there. And we, us talking to ourselves doesn't really do all that much. It's really trying to educate as many people as possible. So you can help play a role in that. So yeah, we'd like to thank all of our supporters there, as well as everybody that has donated. We did have some donations. Wanted to shout out Norm with a $20 donation, continued supporter there. An anonymous 20, $10 from Raven. Appreciate that there, Raven. Lorna D, $10, and then another $20 anonymous. Our friend Scott Ed with a $50 donation. Appreciate that one. An anonymous 20, and it's another 50 from Ed. Appreciate that one. $100 from Stephanie coming in on the website. $10 from Ronald, and $75 from Mary. Lots of support over there. We appreciate everybody that is donating over on the website, and we do take these over on YouTube as well.
I just put one more in the chat for you, Dane.
Oh, yeah?
I'm saving that for you. Go for it.
Bretopotamus.
Nice work.
With a $5 donation. I appreciate this.
Carrie, let's see that.
Yeah, what's the sign?
Oh, she spelled it out. Oh,
that's cheating.
Come on. Nice work, Carrie. All right.
With that, I will tag Phil back in. Thanks, Lou. Yeah. All right. And we're back. And it looks like they are swapping out. So are you ready for some questions? We have questions up on the screen there, or?
Yeah, let's do the questions and discussion.
All right. So really, we had two big questions come through. And they're kind of similar. They're both about that north vent. I'll go ahead and maybe read both of them for you. Paul asks, do you think with all the new holes in the north vent, it might blow open within a few more episodes? Then Madeline asks, is it likely the multiple conduits into the north vent may become distinct vents in the future?
Yeah, it's a good question. Here, put that back on the screen. So all those different holes we see at the surface. So it's hard to know exactly how it will evolve, but we know how it actually started, which was originally one long crack that was a fissure that focused into two spots that are the north and south vents. And then it's piled stuff on top of those exit points, and that has changed the pathway of the exit point up through all the layers that have been added. So I think of it more like a nozzle, and I've used that term before, right? It's almost like you have your hose, but you have like the jet setting or the sprayer setting or the what have you. And that looks like a sprayer nozzle to me right there. It's got a bunch of different holes on it, right? As opposed to just one big one. We did see that when a fountain shot up the last time. It did so. It looks like maybe towards the back, that was back to, right? And split into 2 fountains rather than having 4 or 5. But it's hard to tell when it's all pumping out so much. But yeah, I think so. I think of it more of surface changes, and so how could those change? Could all that area blow out and make one giant hole? That seems possible. Could it keep growing and fill in some holes and change shape? And we've seen that cone on the backside slumping and moving, and so that whole mass of still hot lava can creep along and deform the shape of that hole too. So there's lots of things to think about there, and that's what I'll just throw out there for discussion, really, right? As we don't know exactly what will happen. We know that the structure deeper down is unlikely to change. I mean, there you might consider, is the lava actually hollowing out pathways and enlarging the vent that way, right? And so you had this development to must be a fairly mature conduit now also, right? And so it's really just a surface thing, I would imagine, rather than having it become 2 separate vents, rather than those 2 things being straws that go all the way down, separate all the way. I think they're more fingers that connect not too far underneath into one more permanent, conduit. That's my personal view there.
All right. I'm just looking around to see if there's anything else. Not seeing any more real questions. There was one about your graph when you had that up.
Yeah.
Oh, there we go. Antolian asks, can we have this volume versus days graph with clearer colors? I really like it. Maybe it'll be
I had a better
posting.
version from a few weeks ago. I don't know where I put it, so I ran out of time
Maybe
to make
worth
a
a
better one.
post. Standalone. It's pretty cool. A lot of work into that.
Right, we'll have to update it now. There's more stuff to do, so I'll update it and we'll make a new version.
Right. It's always that chase where you wait a little bit too long, now you got to do it again.
Yeah.
All right.
So but that was the best estimate approach that we found.
Yeah.
Okay, so let's move forward. Let's go to our volcano watch. It's going to be a whole can of worms here in the back half of our update. And so we're going to go in reverse order. We'll start with this week's volcano watch, which is tracking the growth of a new pu'u Kīlauea. So we're talking about the cinder cone on the rim that we've discussed plenty before. And what they're showing here is, let me scroll down in various different views here. But along the prior crater rim drive right there, they've put in a number of stations. You can see them marked with circles here. And these brighter white circles right there are the ones that are shown on a graph, with the one on the right corresponding to the right side and the one on the left side. And from episode 1 to 23, there wasn't as much high fountaining, excuse me, and thus the cone wasn't as big. So that led to a structure that might have been something like this, and maybe it came down. Who knows exactly right there? Excuse me.
Yeah, the profile there is awesome that they were able to give us that.
Yes, they're showing here with each episode and its duration there, right? How much you're adding to it. And so you have some clear winners when the fountains are high and the wind direction is favorable and it's landing on this area. For example, episode 36 here, you can see put out almost 25 feet at the top of this thing by itself, which was also the case for episode 24, where it put out about 25 feet also, right, over 7.5 hours and then over 5 hours. And so you can see there are some times where 27 to 33 that we didn't get quite as many high fountains, so we only have a little bit of accumulation there. For 34, it gets quite a bit of accumulation. 35, not as much. 36, a lot more. So you can see the variation there. And right? 25-foot intervals of dashed lines here on the left. So you're looking at here in the center. Well, it's hard to see exactly where the dashed line would be there, but let's call it 1, 2, 3, 4.5, right? So over 100 feet hill over the rim on this edge over here, and then tailing off on the sides. So yeah, that's get this to, and so they note here, episode 37 is not shown because it had minimal growth. And so now they show the sampling locations there. They show geologists at the top of the cone taking GPS measurement, where they basically have to sit there for a while, for maybe 5 minutes time, to make sure they get a clear, steady signal that they can then have an accurate elevation measurement on. They go through a whole technique to get that, which you can read more about in the article here. But yeah, so this kind of goes through the story of how they got to this, right? They actually began with like go ahead.
I was gonna say they don't have like how tall is it, do they? Now they know that there's how much is getting added to each time. I'm just like, there's nothing on that graph in terms of the Y.
No, it's not in the graph. I think it's here in the text.
I was trying to search for it. I just couldn't. I'm not.
Maybe some of the previous ones, yeah, but I feel like I've seen 100, 130 feet as estimates, something like that. Somewhere in there.
Sounds about right.
It probably depends exactly where and how you measure it, right?
Right.
So they began by photographing the burial of a road sign. By the end of episode 21, they only had an inch or two left. So clearly that was not going to work for much longer. Before and after episode 22, they used a series of 5-foot tall garden stakes. But in the end, 5 of the 12 stakes were buried by episode 23, and another 3 by episode 24. And then you see them backing off of the low-tech methods and turning to GPS, high-precision GPS. So then they have to start hiking out, doing their transects, taking their sites along those data points that you guys saw on the map there. The whole transect taking 2 to 3 hours to complete. After that, they go back and process it all with all their details here and end up with a vertical accuracy of about 4 inches or 10 centimeters or so. So they say that they've tried to use the LiDAR that they've shot into the crater for volumes before, but that hasn't worked so well because the surface is too uniform, essentially there. They note that it grows the most during the episodes that are high fountaining over 1,000 feet. Otherwise, it's hard for the tephra to actually land in this area. So this sentence here at the end is pretty interesting, like how much the landscape has changed over time. Right, so we used to be able to drive from the Jagger Museum, which is now removed and gone, to the Halemaumau Overlook, which collapsed in the crater in 2018. And now in between them, the road that used to connect everything together is getting buried, and there's a new hill that's over 100 feet tall in that same area. So just to show how much things can change and how quickly.
Yeah, it's probably better to use the LiDAR. I would have probably used a giant piece of rebar and just tried to shove it to the ground. Pointed into the air, right? Like, we'll just measure that and it'll be fine.
Have you got 150 long piece of rebar that you can shove in the ground? That's what it would take.
Yeah, up there. You
Right, exactly what they came across as well. So that's Volcano Watch this week. Let's go back to the one last week, which was released on Friday after Thanksgiving. We did our update just before Thanksgiving. And this one was part 2 of this 1975 earthquake, The Legacy, 50 years of study of that south flank. Okay, so that, this is a big topic. We're actually going to talk about the Helena slump here. Maybe everyone can start salivating about that. But this is the story of how this whole debate came to be. Really began with this earthquake in 1975. So we're going to look at this in several different ways. We'll start off here with this legacy, some of the science stuff. We will make our way to some of the survivor stories as well. But to start off, you can see here a GPS station. There's a paper that was published in 1976 that was in review during the earthquake, where they had predicted there was going to be some movement of the flank. Right, so it wasn't very precise or very specific forecast, but they did note that they were seeing signs of the south flank similar to big movements of the past. And so they're trying to untangle essentially what happened with the ground movement along the fault lines during that earthquake. And it's worth noting that the instruments at the USGS on island were all completely overwhelmed. This earthquake was so strong, like basically swamped and flooded all the instruments. They couldn't record the magnitude here because we were too close to the center of it. So they relied on scientists from elsewhere abroad. I want to say New Zealand might have been the leader of the initial determination of a magnitude 7.2 for this event. But since then, we've gone and measured this earthquake and done other calculations, and it's now considered to be a magnitude 7.7 earthquake that occurred in 1975. So 7.7 in 75, epicentered over Kalapana.
Can you zoom in a little on that in the text?
Yeah.
Possible.
Let's make it bigger here. Yeah. All right. So what's interesting is that they've been collecting data over the past 50 years, and in particular, the 2018 earthquake that was reported as a 6.9, at least initially, seemed to activate similar areas as the 75 earthquake. Right. So I'm gonna talk about what's written in here, like through the graphs, right? But there's basically two different ways of looking at this, and so I'm going to turn to this professional paper, 1801. So this is chapter 4, paper 1801. And this is by Roger Denlinger and Julia Morgan. Instability of Hawaiian volcanoes. This whole chapter is really, if you're interested in this Helena slump topic. And what I'll show you is our current view and our current understanding of what the structure of the south flank actually looks like. So here is Kīlauea. Here is the rift zone of Kīlauea with the dikes in this area right through here and a cumulate flowing base. And that intersects with the beginning of this south flank structure, which is bounded by the rift zone and what we call this basal old ocean floor surface here. It's often written as a décollement, which is a fancy French word for this kind of fault. So I won't even spell it or repeat it again, but it's just there's this long flat fault. It used to be the old seafloor. It's just a weakness between the layers, right? And so that is the structure with which the island moves this whole flank seaward. But here is the Helena fault system in particular, and you can see it actually sits like a piggyback. It rides on top and does not connect at depth to this bottom crack and bottom layer. There are splays that come up and we end up having these bulges around the foot of these big flank blocks. But on top of that, you have what you see is termed here a shallow landslide, right? So think about that, a shallow landslide. It's moving more sideways than it is up and down, which is why this idea of the Helena slump being something that falls on the ocean is just misguided. The whole structure of the island can move oceanwards for sure, but you can see it can't really fall into the ocean since it's under the ocean as well right there. But it certainly would move the ocean if it were to slump off, right? But Helena itself is actually this little scallop right on top, shallow landslide. And just to show you guys comparison, here is the original paper that was put out back in 1976 by the USGS with their view at the time of how they thought the faults actually went. Here, Helena fault system with these faults going all the way to the bottom and intersecting and feeding into this pre-oceanic crust, right? And so the reason was because in 75 they saw movement on these faults And they saw movement on this bottom fault through the earthquakes signals as well. But when they walked on the ground, they could see that there was offset on these ones too. And they thought, okay, these must be possibly connected. Or the other alternative is what we now favor. The shaking was so intense down here that it caused this upper part, like a bowl, to slide in its scallop as well. And so that's the nuance of the geology there of how this actually works. And so in more detail, here are some cross sections based on them driving a boat over top of the thing and dragging the data logger behind it and measuring all the layers underneath there. And so they've colored it to make it easier for non-geologists to interpret there. But basically this kind of orangish pink color there is your Helena slump right there. So it sits on top on this detachment of this bottom fault. That's the old seafloor right there. So they don't actually connect, even though there are some complexities and they come close to touching the strands, right? So that's just one line here. So let me show you this next image, which is how this looks in 3D right through here. So there is the head of the Helena fault system right there, and that connects the scallop like this, right? That's this orange pinkish color right there. And then below it, from way up here, not quite Kauiki, but you have feeding into this bottom layer over here as well, this other fault. So that's how it looks kind of in 3D there. You can see there's another area further to the east that is also a little bit of a scallop right there that's had some failure as well, some movement right there. But you see it's not like there's a giant pile of giant boulders at the bottom, right? You know, when you're looking at these debris deposits, if you see gigantic blocks down at the bottom, then you can see, okay, that must have been something catastrophic. Whereas if you see like lots of silt and sand that could be coming off on every day, every week, every year, every winter storm season kind of basis, right? More regularly. So that's one view there, and then here another view slightly farther over, but same idea there, where you see that complexity, right, and all that stuff happening all tied in the same little area right there. And so there is this paper from the group at UC Santa Cruz that combined the modeling for the earthquake, a landslide, and tsunami all jointly. And so it's interesting that you can see some of the data here. Run up was at least 14 meters, 14.3 meters, 14.3 meters, 46 and feet 11 inches. As you see there, closest to Halape there. And so, yeah, they're basically looking at the different models of the failure here. And let me just kind of fast forward there to jump to the conclusion, where in this upper panel, they're showing where the ground is sinking in blue and where it's rising up in red. And this is just from that ocean floor fault, the décollement faulting there, that bottom layer, which is larger, right? And so this is the actual ground movement. And I have superimposed on here some actual data that was collected from on-the-ground researchers as well. And then below here, this bottom panel is the tsunami water displacement, right? So you can see that you can have a much broader effect from the basal fault, but you can have a much stronger effect from the shallower scallop fault. And so in fact, the combination of having both move at the same time, because the shaking was so violent, is what gives you this combined signal that gives you a broad tsunami effect that reaches all the way to Punalu'u and all the way to Hilo and beyond, but also is extremely high and ramps up and does extreme damage in the very near areas because of this helium scallop actually moving itself too. Right, that's the really interesting thing that comes out of this. And so there's some other effects there, right? Like the effects of, let's see here, yeah, how that wave disperses across. I don't want to get lost in the details here too much, but they fit all the waves, and it ends up being the compound that fits best to the observations there. So moving on, I'll show you guys the Volcano Watch article from last week, which is just the beginning part, remembering this event. The largest earthquake of the 20th and 21st centuries to date, right? You can see there a picture of the Jeep surveying which bits of the road are cracked, and you can see that's just one image right there. I'll show you guys a few more coming up as well. So to recap the sequence, there was a foreshock that was a 5.7 that occurred at 3:36 a.m. on November 29th, 75. And an hour and 12 minutes later was the magnitude 7.7. They believe shaking lasted more than 30 seconds, felt across the island and as far as Maui and Oahu. Most of the damage was actually in Hilo, but also volcano, all the way to volcano area, cracks in roads, water pipes, walls, toppled chimneys, collapsed water tanks, rock walls and fences, broken windows, materials on shelves falling and breaking. That's all just the earthquake damage itself. More damaging was a fatal tsunami that swept the island shores shortly afterwards. Campers were awakened by the shaking and rock falls from the pali above. In a USGS report detailing survivor accounts, that's this paper by Tilling and all that we'll look at here in just a minute. They saw the rocks falling first, recognized a tsunami could come afterwards, saw the ocean rising and quickly fled for higher ground, but water overtook them. Most of the campers were swept into a crack, where one described the several tsunami waves as feeling like being inside a washing machine. The water receded about 10 minutes after the earthquake. They note one camper was swept out and never found. Another was drowned or battered to death by the waves. 7 others were hospitalized afterwards. And so we're actually, I know we're going to go a little long to untangle this here, but I would like to do that, to look at the details of this a little bit more closely here from what we can find here today. But before we do that, just to note, the tsunami wrapped around the island of Hawaii, damaged docks and piers, stranded and sunk boats, demolished homes and businesses in Punalu'u, flooded LE Drive in Kona, and lots of damages there as well. So the campground, there was a shelter, there is a coconut grove right there. This is kind of the area of Halape. And after the earthquake occurred, the ground had moved out to sea and dropped downwards, such that this crack opened up and had water sweeping through it. And all the coconuts now were submerged in the ocean and did not live terribly longer past that. They lasted for a little while, as you'll see. So tsunami waves arrived in Hilo just 20 minutes after the earthquake occurred. But it's noted that at Halape, it was only 30 seconds. The earthquake shook for 30 seconds. 30 seconds later, the waves are arriving right there as well. So all of it within about a minute and a half. So here's what you need to know. In Hawaii, when you feel strong shaking, That's the warning for potential tsunami, and people near the coast should immediately head for higher ground. If a local tsunami is generated, it will arrive quickly, possibly before any sirens can be sounded or emergency messages can be issued. Right. So that's the detail of it there. So one final thing here, we have this basically compound disaster here. We have a big earthquake, lots of damage, tsunami with fatalities, and we also had a brief eruption as the final part of this sequence on Kīlauea. Lasted less than a day, began about a half hour after the earthquake, and as a fissure across the floor of the caldera. And so we can look at a couple of pictures of that as well. So to start with, I just wanted to, that's just the link. Let's show you this one account. This, I believe, was compiled by the Tsunami Museum, Pacific Tsunami Museum in Hilo, although it's not the easiest to find online. Here's a picture of the Boy Scout troop at the trailhead there on their way down before the tsunami came and hit. So we'll look at this Boy Scout version of this troop of this first, and then we'll kind of go from there. And so I'll start off by saying I've heard lots of versions of the story, and it's a little bit like these fish tales or a game of telephone where it's hard to know exactly what's real, so it's hard to really untangle. I'd heard that the scout leader had helped the scouts all hide in the crack, and that's how they were able to survive the waves coming across. But I'm not sure that that's quite the truth either, and so I'm not sure that all these accounts are necessarily accurately recounted as well, right? So this is the best of someone's memory at some point later, but still, this is what we have, and here we go. So Michael Stearns was part of Boy Scout Troop 77 that set out for their annual Thanksgiving hike. 10 people in a Boy Scout troop had spent Thanksgiving weekends at Halape ever since he was 12, at least Mike was. So Mike was 16 years old, the oldest scout and a senior patrol officer. They hiked down a trail in light fog. And once down there, 5 boys decided to camp a half-mile south at Boulder Bay, where a new shelter had been built. 4 adults and 1 scout remained at Halape. So down at Boulder Bay, presumably, each scout hung their pack, tying their shoes to the frame of the rafters of the lean-to, right? So this was so that no rats, centipedes, or other animals would surprise them the next morning by being in their shoes, right? They took their shoes off and hung them up, as well as their packs. So on the 29th, you can see Mike reports it as a moonless night, but that contradicts something we'll see later. So not everything can be true. They were violently awakened by a 5.7 earthquake, followed by a 7.2 earthquake that hour later. Get out of the shelter, get behind the rock wall, Mike screamed. The scouts dragged themselves behind a 3-foot wall, hiding on the ocean side of the shelter. Because they were hiding from the boulders, they were crashing down a hillside off of a hill, right? Pali in Hawaiian, it's like a cliff or a hill, like Pali or like the Napali cliffs in Kauai, right? And so those are big landslide areas, and boulders were coming crashing down that they were immediately most concerned about. So Mike decided to return to Halape and check in. Unfortunately, no flashlight worked. Using only a pen flashlight, they frantically tried to untie their shoes from their packs. When suddenly, oh my God, look out. They see water flooding Boulder Bay. He grips a post inside the shelter and clung on as the tsunami shoved him and the shelter to the back of the bay. Suddenly he felt a jolt against his head. That was the first wave. The second wave was even bigger. Mike closed his eyes and repeated, "I want to die fast." This wave slammed him against lava, bushes, and the shelter repeatedly. Mike felt a wave receding and dragging him out to sea. Before it got too deep, he groped for something, anything that could save him, found land, and propped himself up, sprinting to higher ground without his shoes or glasses and completely sopping wet. He touched his head where throbbing pain had begun, and his fingers were covered in blood. So he finds his fellow scouts, Tim, Fal, Leaf. They crossed over the lava, tripping and falling. Mike suppressed his cut with his yellow t-shirt. Fal was their leader, for neither Tim nor Mike had their glasses, and they could not see well. Something don't really consider necessarily in an emergency there is what to do if your glasses get swept by a tsunami, right? Before daybreak, they reached the 1 mile mark to Halape, and Mike stated that's good enough. They sat shivering in a piercing wind for the sun to come up. In the early morning light, a single engine plane cruised above, and Mike sends Fal down to Halape to tell them they need to be rescued. Here they just note, in the end, the Boy Scout leader, Dr. Mitchell, as well as a local fisherman, died in the event. Right, so this is interesting. I myself was not aware that the scouting group had been split in two, right? And that these boys were essentially on their own down at Boulder Bay. And so they get out of there, got lucky. But when they come back, they don't really know what has happened at Halape itself right there. So I found this other account. This is from the now no longer operating Kīlauea magazine, back from 2022, March, April. Donnie's Thanksgiving, first-hand story of Halape's 1975 tsunami. All right, so this is by Leslie Engler and Donnie Cruz. And the Cruz Ohana is the one that the fishermen were part of down there at Halape. So if you just read that one account, you might think it was mostly the scout group that was down there. But really, in truth, it was something like 30 people were down there. And the scout group was less than half of them, honestly. And most of the other ones were this family. Right? So it was Thanksgiving Eve when the Cruz Ohana rode several horses on a long trail to Halape Beach to camp. All 13 of Rico Cruz's keiki were there. The low tide at midnight was our time to pick opihi from the rocks to add to the wedding feast of Donnie's cousin. Opihi are a traditional delicacy that would assure many children to the celebrating couple. 32 people were enjoying the perfect weather on the beach that night. A Boy Scout troop among them had hiked in from the Chinny Critters Road to camp under the trees called Coconut Grove, as they did every year. The Kapuna were gathered uphill at the cabin, talking story, watching the horses that were in a corral beneath Coconut Grove, and overseeing the opihi picking. With campfires burning on the beach, the Boy Scouts told each other ghost stories on this night of a bright full moon. Is it a full moon or is it a moonless night? We'll see. There's some discrepancy here, right? But here's the other part of the Boy Scouts there. Low tide was timed with the highest point of the moon. The pickers went down to the beach with their sacks for gathering and knives for prying the opihi shells that were holding fast. The waves were not large on the south coast of the island that night. The soothing rhythm of the waves as they danced on the beach sang the perfect lullaby of Hawaii. The pickers felt the magic, and then they felt the quake. So I'll just note here, I'm going to scroll down to the bottom of this. There's a ways to go, but they note, this is a story as Leslie remembers it from 47 years ago, or as Donnie remembers it. So they note that the 5.7 earthquake didn't generate a tsunami, but it was two waves from the 7.2 that came later. And so that detail aside, that's something we know that was not the case. And so correct it here in advance here. So let's pick it up right here. The keiki Still awake, picking opihi, looked to the kupuna who had felt the rumbling of Madame Pele many times, but not like this. It was 3:36 a.m. The horses became very restless before the quake, and now were near panic. Donnie's brother, Mickey, went to check on them. Right, Mickey Cruz. All were tied up and safe until suddenly came the crash of boulders flying downhill. The sound came from everywhere, bouncing off Hilinapali and then back again. The opihi pickers didn't know where to run in the confusion until they saw the water being sucked away from the beach, and they knew to run fast away from the beach. A tsunami. But the crashing boulders were coming downhill in a huge wave of their own. Which way was safe? Campers were between two huge powers of nature they could not stop. Most ran uphill. They sensed the thundering sound was a huge landslide bearing down on them, so they ran to the sides. Several took themselves into cracks in the face of Hilinapali, which formed the west side of the bay. Right, so people are running out of their own power is how they're surviving this. There is a Boy Scout troop once again. So the first wave hit 84 seconds after the quake. It crashed on shore in a 5-foot wave. Everyone knew it was only the first. The next one will be bigger. The Boy Scout leader, Dr. James Mitchell, yelled to everyone to run for high ground. They did, and it saved their lives. So there you go. Thomas Amar was looking to help Rico and Dr. Mitchell. Thomas saw Rico and yelled, "Run, Dad." Rico yelled back, "No can, I no more slip us." They ran anyways for the trail leading uphill across the sand. On the Pahoehoe lava trail, there had always been a crack to step across. Now the crack had split too wide to jump across and had filled with water. Several people couldn't see it in the dark, and fell in, including Rico and Dr. Mitchell. Horses, logs, and rocks fell in too, all hitting the sides as the water sloshed. This is our washing machine right here, as people fell in this crack and got stuck in there when the waves rolling around on them. That was when many were hurt, and is apparently when Dr. Mitchell, at least where Dr. Mitchell died. His body was found in that crack. Thomas heard the wave coming right behind him and jumped. The wave picked him up and carried him across the huge crack. The man on a scarred open edge of the crack thought he was holding up his son from drowning, but instead he had Rico unconscious he was holding instead once the wave receded. There is a before image. There's a coconut grove on land. You can see this island and tidal flat offshore before. Here's after. The coconut grove now in a bay, all sunk in. And this crack opened up, which then became a swimming hole because of the water filling it from there. So let's move on here. The second earthquake was bigger at 7.2. The summit moved 4 feet outward and 4 feet down with a mighty shake. 4:48 a.m. and still very dark, with the sky filled with the dust of crushed rock. The roar of crashing rock was even louder than before and just as confusing. It gathered sound as it gathered speed. The screams of horses were just a whisper. Now the biggest tsunami, which I believe was the second wave of the 7.2, crashed on everything that was before it. Even the rocks, still sliding downward to challenge the mountain of water, did not prevail. The wave rose 26 feet above the beach along the poly wall. This is when the very land itself broke off and slid down across what had been the beach. It carried Coconut Grove with it, which settled 10 feet below the surface. Only the top 30 feet of the giant palms were visible. Most of the horses went with it. Big Mickey too. He was not seen again. So this is the fisherman's sister who's recounting this story. Mickey Cruz, the name of the fisherman who died. 19 of the 32 people were injured and 2 were dead. People who were able bandaged and soothed the injured, even though they themselves were exhausted. Rico survived thanks to the strength of the man who held him up. The man's son also survived. A young cousin of Donnie's ran for help in the dark. He ran across Kahuku on a lava path to Chain of Craters Road and up to the Summit Ranger Station, about 18 miles and 4,000 feet in elevation gain in about an hour. In an hour. Only a boy bent on saving his whole family could do such an impossible thing. He reached the ranger station, but the rangers didn't believe he could have done that run in such a short period of time. Rico had registered the trip at the station, listing the names of all the family in the party, including the name of the boy who ran. The rangers didn't believe that either. So they delayed the search until dawn so they could ride the helicopter to the site. They were shocked to find the boy was right, with destruction all that was left behind. And there's a current view of the enlarged crack and swimming hole created by that 75 earthquake there. It took hours and many helicopter trips to evacuate all the survivors. They were taken to the hospital in Hilo. Most were released that day to their ohana with cuts, bruises, and trauma. At least one boy had a broken leg. Mickey was not among them. At the feet of a young boy who was sheltering against Lenaapali was a crack in the ceiling of a lava tube, revealing a burial canoe. 2 paddles were crossed inside. There was a split following the grain at the bottom, making it unsuitable for paddling in the sea, marking it as a burial canoe. This was also removed by helicopter and taken to the ranger station to be sent to Bishop Museum. I'm not sure if that's what you would do today, but the same type of canoe had been used for carrying the body of Kupuna across the uneven lava at the base of the pali to their final resting place. Each family owned their own sacred crypt, made for them by Madame Pele as lava tube openings at Lenaapali. The bodies and cremated remains of their family had rested safely there for hundreds of years, and now they were revealed. So the end of the story, this right up here. In Ka'u, there are still kupuna who know the ancient Kanaka Maoli Native Hawaiian ways of divining the future. They told Mickey a few years before the tsunami that he would pass at age 27 in a tragic accident, which made him reluctant to go opihi picking that night. It was to these kupuna that Rico turned for help to find Mickey. Donnie had searched the beach for her brother, found his picking bag, his knife, his belt. They chanted and prayed for knowledge of where he was for 4 days, and then told Rico they saw Mickey buried underneath 3 crosses. So they go back to Halape. They see the 3 crosses of the horse corral gate washed to see atop of the rocks that buried Mickey. So there he lies today with the prayers and blessing of his ohana. To this day, his sister Donnie takes ho'okupu offerings to chant and pray for him on his birthday. And they've done this for over 45 years. Right, this story written just 3 years ago in 2022. Right there. So there's definitely a lot there, and I thought this was interesting. I then found the national park made a post about the tsunami as well. You can see some of these similar images in here as well. Really, really tiny version of it. But interesting, if you come into the comments here, you see people mentioning Mickey Cruz, the horses lost at sea, right? Dr. Mitchell in there as well. People elsewhere on the island being shaken out of bed, Honomu. One of the scout troop members that by luck didn't go on that one particular camp out and stayed home Right? So there's lots of people that are around talking about this story, right? Which is interesting. So the scout leader was a surgeon. That's true. In fact, he was a surgeon who helped Jeff Judd after he fell in the lava and treated him for his recovery. So a lot of connections through all of that as well too. Right. So yeah, more family members chiming in here. Yeah. So it all comes together there. I thought I could show you a couple other things. There's some other images from the Tsunami Museum showing there's a scout troop location of Halape. This is some really blurry, low-res images here that we'll just kind of go through and see what that looked like after the palm trees had died, sitting in the ocean for too long. And then further along at Punalu'u, houses that got swept off their foundations and damaged by the tsunami. This one carried inland. You see the Nino Ola Hills there in the background. So there is this paper that was issued, preliminary report, shortly afterwards by the USGS. And there's a lot of stuff in here, but I thought I would just show you guys some of the images at the very least. Damage in houses, right, with people being trapped inside to not get out safely. Grocery store in Hilo, and all the goods all over the floor. This is the KMC, where the chimney fell through the roof into the dining room with the earthquake. Right there. Hilo High School, the roof falling in there. This one here, whereas this is a churchyard in Curtistown, granite headstone toppled, they're replacing. And so really amazing images there. More collapsed concrete pier finger. Here's a coming up to the bottom right here. This is the foundation of a warehouse at Honuapo Harbor, past Punalu'u down the coast. The house shoved 25 yards off its foundation at Punalu'u. At Punalu'u, they had the resort down there, the hotel and resort, and here is the piano from the lobby washed out of it. Other houses at Punalu'u picked up and smashed. Cars tumbled and flattened. See, this like a chair up in a tree here. It's up by the ponds. This over here is in Keho and Kona. Powerboat washed onto the dock all the way in the Kona side.
Hey, Dano and Carrie, I know it's 7 p.m. and you guys got to get out of here. Appreciate you guys for sitting in with us for this longer episode.
Yeah, so we have here further on at Keho, more damage as well. And so that's some of the images to show you guys, as well as the actual eruption that occurred. Here is the fissure on the floor of Hale Ma'uma'u, as you see it from the ground level, spattering. And from the air, there is a main crater of Hale Ma'uma'u. There was a couple of small vents at the bottom of this cliff, just over the lip here, with a main crack coming off near the 54 fissure trace, interrupting this small pad of lava just over the course of, I want to say it was like 19 hours or something like that. So those are some of the images there. And we got some more as well here. There's the before and after. There is the top of the island and the coconut tree submerged. From the ground level, the waves sweeping through the coconuts. At Keho, hard to see, but there's actually some buildings, coconut trees over here. And you see this little rocky cliff right there. And we come to here and there is no sign of any of that. It's all underwater. There's a coconut tree sticking up there. Some different views there. There is the actual poly. So Halape campground is down over here. Right, so you can imagine all those boulders were coming off of this big cliff right there. Right, and you can imagine a tsunami wrapping up the wall might have gotten some height right up there too, because it's so steep as well. Here they note a vertical offset of 1.5 meters along that new fault. I'm going to go and look at that area after the fact. This is up in a national park. This is Pauahi crater overlook, which part of it fell into the crater, as you can see there. The railing is hanging off the edge. There is a different view with the rest of the overlook also pretty compromised right there. Cinder cones on the Chain of Craters Road falling over onto the road. Lots of damage along Chain of Craters Road there. Little folds. We got some better versions of some of these too to show you guys. Maybe I'll move past that one there. But there's some other interesting things that are noted in here as well. Let me see what else we can quickly share with you. There are, for example, here, measurements of cardinal points around Hawaii Island. If Hawaii Island was a clock, right, with 0 being up Honoka, 90 being Hilo, and elsewhere around, you can see 75 had the highest run-up of the waves at Halape, right, on the south side, similar to 1868, but different from 1946, 57, and 1960, which had different first impacts and higher run-up points right there, if you're curious about that. And there was another thing to highlight too as well. Not sure if I'll find it here though, before we wrap it up. Here we go. This is the run-up heights of the wave, right? So 14.6 feet, 1312 right here in a Halape Point area. Punalu'u, it was over in a range of 6 meters or so 18-20 feet, somewhere in there, right? You can see wrapping around 3 till you get to Mahukona, and it's not noticeable on the very north tip of the island, right? You're looking at 1 meter, 2 meters in Lapahoihoi, 1.5 meters in Kawaihai, right up there. So that's the distribution. I'll show you guys a few more of these images in a little higher res. Those palm trees. You can see this is right afterwards. They're all still, the leaves are healthy and not droopy at all, right? So here's a couple of days afterwards. There's a crack. See some water in it right there. The tree's drowning and the leaves looking not quite so healthy. There's that crack with the water again right there on the side. And then later on, you can see the trees dying, and we showed you guys that other image earlier as well. Puhimau by Pauahi, the Jeep. And again, Crater Rim Drive. Some different vehicles, lots of damage all around to assess. Everyone wants to get a look. So, thing there, and then the eruption itself there too. So yeah, I'll stop it there. That's just a little bit more to share. Obviously, we can't be comprehensive on everything, but I thought it was worth reliving this. After 1868, this 1975 sequence is our next best example of compound disasters here, Dane. Earthquake, tsunami, eruption combination. In 1868, we got it twice. This was just a one-off thing, but still big enough to cause that Helena slump scallop to shake, which didn't quite happen in 2018. So just goes to show, right? And one final thing to note, I heard Ingrid say this one of her interviews, that 6.9 earthquake in 2018 would it be 16 times smaller than a 7.7 event that occurred in 1975. 16 times smaller.
Yep. That magnitude scales doesn't intuitively work the way you think it would. Things get a lot bigger, a lot quicker. But yeah, we've definitely, we've talked about it before, and we'll talk about it again, just because it's, one of the main hazards out here is the ones you can't prepare for is the sudden onset earthquakes. When we talk about tsunamis, and everybody wants to talk about like the tsunamis from Alaska or Japan or Chile, it's like, yeah, those are important, but they have several hours of lead time before they get here. We know what we're getting, at least in terms of the ballpark estimate. Now you can believe the data or not believe the data, like with the last one, right? But you have an idea. The freak ones that happen here, you have no time and you have no data. There is nothing. That siren, I doubt it will sound, type of thing in time. It'll sound 10 minutes after the waves have already cycled through your neighborhood, type of thing.
So let's give
rely on
Subsidence credit. They did sound the sirens in Hilo, which got waves 10 minutes later, right? So they did get that. They did get that off, but like 30 seconds. I mean,
yeah,
there's not time to, you just got to run.
Well, even at
You got 30
Poikia, that
seconds.
you don't have time. Like nowhere really has that much time other than the other side of the island type of thing. Then you start to have the time.
Yeah. The thing is, you're not sure, like, was it earthquake epicenter near you, or was it 20 miles away from you, and you still felt it because it was that big, right? That's the hard thing to kind of judge instantly. Right. So that's why the overall advice is, if you're by the ocean and you feel the ground shaking or you have trouble standing, like that's a big enough earthquake to generate tsunami. You just go and land a few blocks.
And like
Just
even
start
USGS,
moving.
the websites and all of the, unless you have like a live type of thing and you're able to actually interpret the data in real time, you don't have anything and it's not worth waiting for it. Right? No. Waiting for to figure out where your earthquake app is going to tell you where the earthquake is. If there's a wave, it's already there by the time that app updates, type of thing.
Oh yeah. You feel it, you start moving. That's what you got to do. Yeah, that's the education we're trying to give you. If you remember nothing else, then that's the lesson to take. And take everyone else with you when you're going inland. And you don't have to like move super fast. These waves come in 15-minute cycles, but you just gotta you don't have to go like super far, right? I think being in a science museum and looking at their model of Hilo, you look at like where the wave was actually reached. It's only like 2 or 3 blocks inland, really. Like, so if you can walk 3 blocks, that's probably enough in 15 minutes. Just start moving, right? Don't get all your crap. Like, tell your loved ones, go, don't dally. But that's what you got to do. Immediate action. All right, Dane, we've covered this. I mean, I guess I could go into more details today to talk about like how many horses died and like more of the counts. There's way more
into detail,
but like,
really.
There's more. There's way more.
I mean, it's not the end all be all everything that happened in 75, right? It's a dive into it.
Just letting you know, like you can go back and read that tilling paper and find even more details of the accounts and even more of the clues to what maybe actually really did happen in there, right? How many waves actually came, how people were trapped and stuck in there. But you can see there's an element of truth in all those different accounts there. Like it's kind of combine them all together there. So in this image here, I'm not exactly sure where the Boulder Bay is, but you would imagine it's got to be somewhere down over here, right? Boulder Bay, where the splinter group of scouts was camping away from the main pea pickers and other scouts. Yep. All right. Well, thanks, Dane. Thanks, Lou, in the back end. Let's say mahalo to all of our viewers who are watching us either live or on replay here. If you made it to past the 2-hour mark here, we appreciate you. And we'll be back next week at our usual time. Let's see, guys, anything to add?
Nope.
No? All right.
That's it.
So for Lou Atori and Dane DuPont, our ASL interpreters, Carrie and Dano, I'm Philip Ong. Until next week, aloha, everyone.